Alright, now that we're all experts in exponents, let's talk about polynomials. But before we can talk about polynomials, let's talk about a monomial. So a monomial, think about mono, solo, one. So a monomial is one term. For instance, it could be 14. It could be 7x. It could be 2y. It could be 6. It could be 10. Could be 1354a. Those are all single terms, so they're all monomials. So a polynomial has many terms, multiple terms, and we have some special ones. We have a binomial, has two terms. So for example, 6 plus 4y. There are two terms, I cannot combine them, I can't simplify it. Two terms, binomial. We also have a trinomial, which is three terms. And an example of that could be 6 plus 4x plus 3y. I can't combine the x and the y because they're not like terms. So I have three terms. So those are the special types of polynomials. A polynomial could have 10 terms if it was that crazy. Let's look at the monomial 7x. Well, 7 is the coefficient of x. And hopefully you guys remember that, but it's the coefficient of x. So 7 is the coefficient when we have 7x. And if I have 7x and 3x, these are like terms because they have the same variable, just perhaps different coefficients. Sometimes they will, sometimes they won't. And when you're looking at a polynomial, you want to simplify by combining like terms. So in this example, my like terms are 3x plus 2x plus 7x, which is 12x. And so we'd have 12x plus 4 would be our simplified version. So here I have this monomial 4x cubed y z squared. It's one term because they're all multiplied. There's no addition or subtraction. That's what separates terms, multiplication. They're all together. And I might want to talk about the degree of a variable. So perhaps I want to talk about the degree of x. Well, it's the exponent of x, so here it's going to be 3. The degree of y is going to be 1. And the degree of z then is going to be 2. So if I look at the variable, the degree of variable x is 3. But sometimes I might want the degree of the monomial. So this is the degree of the variable. If I want the degree of the monomial, it's the sum of the degrees of the variables. So in our example here, it's 3 plus 1 plus 2, which equals 6. So the degree of a variable is individual variables. The degree of the monomial is the sum of those variable degrees. And we'll need that every once in a while, and I'm going to show you when we'll need that. Well, what if I want the degree of a polynomial? So the degree of a polynomial is going to be the highest, so the highest monomial degree after it is simplified. And that's a big one. I'm going to show you why. So let's look at the example, minus 6x cubed plus 3x squared plus x squared plus 6x cubed plus 5. So I want to simplify this. So I'm going to use different colors. Sometimes I use different style lines, but I'm going to underline my like terms. So I'm going to underline my x cubes in red, and then I'm going to underline my x squareds in blue, and my constants I'm going to underline in orange. So if I combine like terms, negative 6x cubed and a positive 6x cubed gives me 0. Then I move on to the squareds. A positive 3x squared plus x squared is a positive 4x squared. And then my constant, I just have the 1, so it's just plus 5. So my simplified equation is 4x squared plus 5. And in this one, my highest degree is 2. So the degree of this polynomial is 2. And we don't use that too often, but you are going to sometimes want to put them in descending degree or ascending degree, so either they get bigger or they get smaller depending on what you're looking at. Typically, we want to write our polynomials with the highest exponent on the left of x anyways, and then they get smaller as we go to the right. So now that we know what polynomials are and how to describe them, let's look at actually working with them. What if I want to add these two polynomials, 4a squared minus 3ab plus 9, and 2a squared plus ab plus 2b? Well, the first thing I want to do is I want to write them so that I have everything kind of lined up. So I'm going to go 4a squared minus 3ab, and I'm going to skip a space, and then I'm going to do plus 9, and then my other polynomial is 2a squared plus ab plus 2b, and then nothing else. So notice how I lined them up so that I actually have like terms one above the other, and I can actually just add like I normally would. So 9 plus 0 is a positive 9, 2b plus 0 is a positive 2b, a negative 3ab plus a positive 1ab is going to be a negative 2ab, and 4a squared plus 2a squared is 6a squared. So when I want to add polynomials, I line up the like terms and then just add like terms. Should be pretty easy, right? Well, what if I want to do this? What if I want to subtract? And I say subtract 2x squared minus y squared from 5x squared plus 7xy plus 2y squared. Well, remember, if I'm subtracting from, that means I'm going to reverse them when I write them down. So just like addition, I'm going to write them one on top of the other. Alright, so now I lined up my like terms, but remember we're subtracting this whole bottom. So I really need to distribute this negative to the 2 and then to this negative y squared. And that's going to make this positive and this negative. So 5x squared minus 2x squared is 3x squared. 7xy minus 0 is 7xy. And 2y squared plus y squared is a plus 3y squared. Well, what if I don't like writing them one on top of the other, stacked like that? Or what if it's not given to me in that way? Well, what I can do is I can do 6x squared minus 3xy plus 2y squared plus 3x squared minus 3xy plus y squared. And I can, since this is addition, I don't have to change any signs. So now I can just go ahead and find my like terms and combine them. So again, I'm going to underline all of my x squareds. In red, I'm going to do my xy's in blue, and I'm going to do my y squareds in green. Notice I don't have any constants in this example. And so I've got 6x squared plus 3x squared. So that's 9x squared. I have negative 3xy plus negative 3xy. Their signs are the same, so I add them. So it's negative 6xy. And then I have a positive 2y squared and a positive y squared. And that's going to give me a positive 3y squared. So my simplified polynomial, after I add those two, is going to be 9x squared minus 6xy plus 3y squared. Pretty simple. Now remember, it's a little trickier with subtraction. Okay, this one's a little hard to read, so I'm going to read it to you. But it says subtract 4x minus 2y minus z plus 1 from negative 2x plus 3y minus 5z plus 2. So I'm going to rewrite them, and remember, since I'm subtracting that first polynomial from the second one actually is written first. So I'm going to do negative 2x plus 3y minus 5z plus 2 minus, in parentheses, 4x minus 2y minus z plus 1. So here, it's the tricky part. I need to distribute this negative sign to the whole polynomial, so that what I end up with is my first polynomial plus negative 4x plus 2y plus z minus 1. I turned my subtraction into addition, distributed that by distributing my negative sign. So now I'm going to just do what I've been doing. I'm going to underline my like terms in different colors. Perhaps what you're doing, since you don't have different colors, is you're going to use different style of lines. And then now I'm going to combine. So I get negative 6x plus 5y minus 4z plus 1. And there is my simplified polynomial. So you can do it this way, you can do it the other way, but you have to understand sometimes it's going to be given to you in this form, and you'll need to be able to do it. Whichever way you want to look at it, you're going to have to be able to take this statement and make it work for you. Alright, so go do the check-in.